Hey everyone, my name is Mayur Srinivas and welcome to this tutorial as part of STEM Leaders of Tomorrow. Today we will be looking at the basics of the breadboard circuitry, the first video in the breadboard series. First, I will be talking about the basics of circuitry, looking at a few simulations, and then applying it to the breadboard. So there are essentially two types of circuits, series and parallel. In a series circuit, there is one path for the current to flow, leading to the fact that if one component of the circuit is broken or not working, it would affect the overall circuit. For instance, let's look at the series circuit depicted above. The battery is providing voltage, which propels the current around the loop. The purple arrows show the movement of the current, which is acted against by the resistors, providing a resistance to lower the current. Now let's look at the parallel circuit. In this type, the current can select whichever path it wants to, usually the one with less resistance, leading to the fact that a broken component will not necessarily affect the entire circuit. The main aspects are the same in parallel as series, except that there are more choices of flow for the current. For instance, in the depiction shown above, the purple arrows are varying, showing the extent to which current chooses its path. Now, hopefully this provides a general overview of what circuits are, because they are the basis of what occurs in breadboards. But before we can look at that, let's just look at a simulation where we construct circuits. So we can start off by constructing a series circuit. Here are all of the necessary materials for the circuit, so we can start off with the battery, which is the first step. I'm going to model the series circuit that we had seen before, involving the wires and resistors. Now keep in mind that light bulbs are resistors. The filament inside of them provides resistance to the current. However, if there is no resistance inside the bulb, then no light is emitted. Therefore, for the maximum light to be emitted, a small amount of resistance must be present. Also, the reason I am using resistors is for a visual element and understanding what changes the bulb's intensity. So I have placed 2 resistors and a light bulb, essentially 3 resistors overall. And once I close the switch, we can see that current starts flowing throughout the circuit, illuminating the bulb. Now what we can do is try to see how can we change the bulb's brightness. So let's start by reducing the resistance of these resistors. Once I do this, you can see that the brightness of the bulbs increase. And the reason for this is because since there is less resistance, more current is able to pass through the bulb, illuminating it even more. Another way to increase the brightness is by increasing the voltage supplied. So if we increase the voltage supplied by the battery, we can see that the brightness also increases. Next, let's look at a parallel circuit. It is similar to the series in terms of materials, but does have a different structure. I'm going to model the parallel circuit we had seen earlier in the slides and use multiple resistors and bulbs. Remember, light bulbs act as resistors since they do provide resistance to the circuit. Here we see that all the bulbs receive similar current, but what happens when one of the bulbs has a great resistance? Let's try that. If I increase the resistance of the first bulb, it decreases in brightness as less current flows through it. Therefore, we can determine that current wants to pass through components with the least resistance. So that was just a simple introduction to circuits, and I hope this visual component of circuitry was helpful. I'll put the link to the simulation in the description, and I really encourage you guys to play around with it, as experimenting is the best way to learn. Now we are going to get into the cool stuff, using our hands to model circuits on the breadboard. So this is a breadboard. It looks pretty simple, with a bunch of holes and numbers. These numbers are really important as they distinguish the various rows and columns to base our models off of. So let me quickly explain the main point of the breadboard. It is to model circuits, but how can this piece of whatever this material is model circuits? Well, the idea is the flow of current. There are 2 rows between the 2 sets of red and blue stripes, and in these rows, current flows across each row, from left to right and vice versa. For example, if I place a component in this first hole and one in the last hole, current will flow between them. You can also see the plus and minus sign on these rows. These represent the positive and negative terminals. two wires are inserted to these two rows, where one is the positive end of the circuit and the other is a negative one. Remember that conventional current flows from positive to negative. Next, let's look at the middle part of the breadboard. In this section, current flows from top to bottom in columns. Due to this, it makes no sense to place two ends of the same component in the same numbered column, like this, as it is not doing anything since current is already flowing through the column. Finally, you can see that there's a gap separating the two halves of the board. Current does not jump over the gap, so it stops current. Therefore, wires are needed to transfer current from one to the other. So now that we have learned the basics, let's go through the various components quickly. First up, we have the breadboard and wires from that. These two components, acting together, supply the voltage to the entire current, with the red wire acting as the positive terminal and the black wire as a negative terminal, also called the ground. Next up, we have the wires, which are just used to transfer the current from one hole to essentially anywhere you want around the board. Next, we have the resistors, which provide resistance. Additionally, we have the LEDs, which also play as resistors and also provide a visual aspect to let us know that our circuit is working. So as of now, we have learned all the basics of the breadboard. Let's start modeling to get a visual aspect. We are going to start with a simple series circuit, meaning that the current only has one path to flow through. We are going to start by connecting the positive wire to the positive terminal in essentially any of these holes, but I'm just going to choose the first one to increase space. Remember that current flows across this row, so I'm going to place a wire right next to it, even though it would work if placed anywhere on the row. The other end of this wire can now be placed absolutely anywhere on the board, since current is being transferred from positive terminal to another hole. So I'm just going to place it in a near proximity. Based on our original model of the series circuit, we now need a resistor. I'm going to take a resistor and place it underneath the wire. Remember that in these sections of the breadboard, current flows across the column, not row like before. So current is flowing from anywhere from the near end of the wire to this end of the resistor. We can place the other end of the resistor anywhere, so I'm just going to place it here. I'm going to take another wire and do the same thing and cross the gap. Current is now flowing from the positive terminal through the wire, through the resistor, and finally through this wire. Now let's place an LED for a visual aspect. I'm going to place one end underneath the wire and the other end somewhere around that area. Next, another wire will be used to bridge the gap once again, just in the other direction. Now I will use a resistor and LED connected to each other. The resistor will be placed above the wire and the LED will be placed above the resistor. Notice that I am just playing around and using various components to include variety. Finally, we need to close the circuit, so I'm going to use a wire to connect one end to the far end of the LED and place the other end in the negative terminal row. Remember that current flows across each row in this case, so when I place the negative wire into the negative terminal, the circuit is essentially closed and we can start to see the bulbs illuminate. We could have also just used the negative terminal all the way at the bottom, but we can use that another time. I just wanted to show you guys the process of making a simple circuit on the breadboard. So that was just the series circuit. I'm going to model a parallel circuit, meaning that the current can flow in various paths. I'll go through this faster, as we know the basics already. So we start by inputting the positive wire and attaching a wire to a nearby hole. We place the other end anywhere we want, and now we have to think, how do we model this so that there are multiple paths? So it's pretty easy, we just have to play around. We know that current flows down the column here, so we can have multiple components along this column. So it will look somewhat like this, with wires going in all directions. I'm going to attach more wires to make more paths. Now we can add the LEDs and resistors inside these paths, and then attach more wires at the end to close the path. Finally, everything is coming back to one spot, where we can use the final wire to close off the circuit. After placing the negative terminal, the circuit is now closed and the LEDs are illuminated. It might be a bit difficult to see where each end is located, so here is a view with the smaller wires. I just chose the larger ones because they are easier to work with. So that's pretty much it. We have modeled both a series and parallel circuit on the breadboard. Breadboards and components aren't too expensive. You can just purchase them on Amazon if you would like, and experiment with them. Once again, experimenting and trying it yourself is the best way to learn. Thank you so much for watching this tutorial and have a great day.